Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss last in first out page replacement algorithm. Last in first out page replacement algorithm works on the principle of LIFO, that is last in first out. A stack is implemented in order to hold the pages with the newest page being placed at the top of the stack. Here, the newest page is replaced by the requested page in situation of page fault. So whenever page fault happens, the newest page that is placed at the top of the stack will be replaced by the requested page. That is what is stated here. So on page fault, the page at the top of the stack is replaced. Now let us go through some of the advantages and disadvantages of first in first out page replacement algorithm. So advantages, so it is easy to understand and easy to implement, and computationally it is very simple. Now let us go through some of the disadvantage of last in first out page replacement algorithm. Now last in first out page replacement algorithm does not consider any factor for replacement, hence may produce worst performance. So as in case of first in first out, so since first in first out did not also consider any prime factor for replacement, so it led to a poor performance. So in case of last in first out as well, since last in first out does not consider any prime factor for replacement, so hence it may produce the worst of performance. Moreover, in case of last in first out, since the page that is there at the top of the stack is always replaced to make space for newly requested page, it may so happen that a set of pages may reside in the memory forever even if they are not being used. So we will try to understand last in first out in greater detail with the help of an example. Now let us consider we have 4 frames and there is a page reference string as specified. So as discussed in the other page replacement algorithm, page reference string basically highlights the sequence in which the pages will be requested for by the process during the course of execution. Here P refers to pages, H refers to page hit, M refers to page miss, F1 to F4 refers to the 4 frames that are there. So as said earlier, page hit refers to a condition when the requested page is found available in the memory, and page miss refers to a condition when the requested page is not found available in the memory. For simplicity, here page hit and page miss is represented with asterisk and hash. Now we have a 2-dimensional representation of the 4 frames, the page hit and the page miss. So now let us try and create a representation of the page reference string over the 4 frames using last in first out page replacement algorithm. Now initially we have a reference to page number 1, so page number 1 is not available in the memory, so page number 1 will be brought into the main memory through replacement. But here, since there is no frame to be replaced, so it's simply placement of the frame. Now after 1 we have a page reference to page number 0. So since page number 0 is not available in the memory, so page number 0 is brought into the main memory. Then after page number 0 there is a page reference to page number 2. So since page number 2 is not available in the memory, page number 2 is brought into the memory. And after 2 there is a page reference to page number 4. So page number 4 is not available in the memory, so page number 4 is brought into the main memory. Now for these 4 initial pages, which are 1, 0, 2, 4, no replacement is required because the frames were initially empty. From this point onwards, any page that is to be brought into the main memory calls for replacement because now the frames are completely exhausted. After 4 there is a page reference for page number 8. So since page number 8 is not available in the memory, it has to be brought into the memory by replacing a suitable page. So out of 4 to 0, 1, 4 is at the top of the stack, so what I'll do is I'll replace 4 with 8. and we have the new orientation of the 4 frames as 8, 2, 0, 1 respectively. After 8 I have a reference to page number 9, so I'll replace the page that is there at the top of the stack. So I'll replace 8 with 9, so the new orientation of the 4 frames will be 9, 2, 0, 1. Now after 9 there is a reference to page number 5. So since page number 5 is not available in the memory, so what I'll do, I'll replace the frame that is there at the top of the stack. So I'll replace 9 with 5. Now after 5 there is a page reference to page number 2. So since page number 2 is available in the memory, so there is a page hit. So whenever there is a page hit, you need not replace the page. Now after 2 there is a page reference to 13. So since 13 is not available in the memory, so what I'll do, I'll replace the page that is there at the top of the stack. So I'll replace 5 with 13 and make space for 13 in the 4 frames. Now after 13 I have a page reference to 0, so I have a page hit here, so no replacement is required since there is a page hit. After 0 there is a page reference to 1, so page number 1 is already available in the memory, so again we have a page hit, so no replacement is required. Then after 1 there is a page reference to 11, so 11 is not available in the memory, so I need to replace the element that is there at the top of the stack, or the page that is there at the top of the stack, with the requested page. So I'll replace 13 with 11. Then after 11 there is a page reference to 4, so since 4 is not available in the memory, I'll replace the element that is there at the top of the stack, or the page that is there at the top of the stack. So I'll replace 11 with 4. Then there is a page reference to page number 9, so since page number 9 is not available in the memory, I'll replace the page that is there at the top of the stack, so it's page number 4 being replaced. Then after 9 there is a page replacement reference to page 11, so page 11 is not available in the memory. I'll replace the element that is there at the top of the stack, so I'll replace 9 with 11. After 11 I have a page reference to page number 12, so page number 12 is not available in the memory. I'll make a suitable replacement, so I'll replace the element that is there at the top of the stack, so I'll replace 11 with 12. After 12 there is a page reference to page number 9, so page number 9 is not available in the memory, so I'll replace the element that is there at the top of the stack. I'll replace 12 by 9. Then I have a page reference to page number 8, so since page number 8 is not available in the memory, I'll replace the element that is there at the top of the stack by 8, so I'll replace 9 by 8. After 8 I have a reference to page number 5, so page number 5 is not available in the memory, so I'll replace 8 with page number 5. Then I have a page reference to page number 4, so page number 4 is not available in the memory. I'll replace the element that is there at the top of the stack, that is page number 5, with page number 4. Then there is a reference to page number 8, so page number 8 is not available in the memory. So what I need to do is I need to replace the element that is there at the top of the stack, so I'll replace 4 with 8. Then I have a reference to page number 3, so page number 3 is not available in the memory, so I'll replace page number 8. Then there is a reference to page number 1, so page number 1 is available in the memory. So now what I have is I have a page hit, and eventually I have a reference to page number 0, so again I have a page hit. So here in this example we have seen that in case of last in first out, the element that is there at the top of the stack is being replaced by the requested page. So the tendency is that some of the pages may always reside in the memory even if it's not being utilized. So here if you count, we have 5 page hits and we have 19 page misses. So here what we need to do is we need to calculate the page hit and the page miss ratio. So page hit ratio will be 5 by 24 into 100, whereas page miss ratio or page fault ratio will be 19 by 24 into 100. So as in case of FIFO and optimal page replacement algorithm, so here there are 5 page hits and 19 page miss. So your page hit ratio will be 5 by 24 into 100, and page miss ratio will be 19 by 24 into 100. So that is the way how the page hit ratio and page miss ratio will be calculated in case of last in first out page replacement algorithm. Now in today's class we have learned about last in first out page replacement algorithm, the way how it works. We have discussed some of the advantages and disadvantages of last in first out page replacement algorithm, and we have elaborated on last in first out page replacement algorithm with the help of a very simple example, where we have seen that the tendency is towards replacing the element that is there at the top of the stack, which may result in pages staying in the frames for prolonged period of time, even if it's not being utilized. So this is the end of the class. Thank you very much. Have a good day.